Hello and welcome to the session on base and derived measures. In this short video, what we would really try to do is to look at some examples and try to understand the concept of base and derived measures in software projects. So in order to really distinguish between base and derived measures, let's first try to talk about a very different scenario. Let's talk about ourselves. The question is, what will be the numbers you will use to describe yourself? And just think of numbers that you will use to describe yourself. Just think for a couple of seconds, and then we will look at what possible numbers we can use. All right. So it will be these things like height, weight, hip or chest size, age, amount of blood in the body, that's also a number, amount of sugar content in the body, again that's also a number. So and there could be many more numbers, right? Now these are all describing some facets about the individual, and it talks, it describes some things, but does it really indicate the health of the person if that's our objective? May not be. These numbers are good to know. It describes certain things, but it doesn't really help us to take any decision. A doctor, for example, would not be able to give you anything or any kind of an inference based on these numbers, right? So what would a doctor really need? A doctor would have to look at things like the body mass index or the cholesterol, which is expressed as milligrams per deciliter. Sugar content again as milligrams per deciliter, and of course there could be many more numbers like these things, like for example the pulse rate, which is the number of heartbeats per second or per minute, and so on and so forth. So this indicates the health of the person, and the doctor looking at these numbers would be able to say, is a person in good health, or is he above average, below average in his health, does he need any medication, and things like that. So in the first set we saw some plain numbers like height, weight, age, etc. And in set 2 we saw some numbers that really helps the doctor to take a decision. So what is the significant difference between these two sets? The answer lies in the fact that set 1 are base measures, which is a single unit, or each one has a single unit associated with it, and it is a single absolute number. So for example, weight is it's represented as kilograms or pounds, but it is a single number. Similarly, height, chest size, and so on and so forth, these are absolute numbers. So we can call set 1 as base measures, whereas set 2 are derived measures. In set 2 you would have noticed that all the numbers are ratios, and it is derived from one or more base measures, and it's always expressed as a ratio. That is the biggest difference between set 1 and set 2. So you would have got this point that it is the set 2 that helps you to get inferences, because it's always ratios that helps you to get inferences. And that's true in not just the health of the person, but it's true in a financial world, it's true in any other things, right? For example, you talk about a country, gross domestic product is one metric, but then that's just a number that indicates how big that country is. What really indicates the country's economic stature or the ease of living would be metrics like per capita income, which is a ratio, right? Or it could be GDP per person, which again is a ratio. Those are the things that will indicate the health of the country. So similarly, what would be the metric that indicates the health of software projects? If we are able to answer that question, then we have really understood derived measures in software. So before jumping fast into the derived measures in software, let's first understand base measures in software projects. Now, a lot of people think that metrics is a very complex topic, and there are a lot of numbers, very difficult to collect it, very difficult to analyze them, and so on and so forth. So let me try to just demystify that whole thing. Now, if you look at the base measures, fundamentally there are 4 base measures which are most commonly used in all software projects, and those are size, effort, defects, and schedule. And these 4 hold good for any type of project. Each one is an absolute number, and it will have a unit associated with it. There could be other base measures also, like for example the number of risks, the number of requirement changes. There could be some product quality metrics, like coupling between objects or cyclomatic complexity of the code, and so on and so forth. There are additional numbers, but the base measures which are most commonly used would be size, effort, defects, and schedule. So that's really the first lesson for us to demystify that whole thing, that it's just these 4 base measures that really is the crux of software metrics. And a lot of health of the project, a lot of metrics that relate the health of the project can really be computed from these 4 base measures. So what would be the derived measures that we can compute from these base measures? Very simple. And again, this would be something of a common sense, like productivity, for example, right? Defect density, which is an indicator of the quality. Schedule variation, effort variation, cost of quality. All of these are derived metrics. So please note that all of these have a definition, and all of these have a numerator and a denominator. It's a ratio. Now, by looking at the derived metrics now, we can really measure the health of the project, because we would be able to judge whether is the project doing well or not. We would be able to judge whether the project is better than other projects. Is it the best in class? Is it really something where a lot of things needs to improve or not? Those kind of decision can really be made by looking at these derived measures. So the important point to note is that these derived measures help us to infer on project performance, and that is really the goal of software project metrics, right? Now, so just for the academic sake, the definitions of some of the metrics are given here. Elsewhere on this website, you will also see a very detailed spreadsheet that lists down all the definitions and the purpose of various derived measures. But there is a minimum set, maybe around 6 or 7 software metrics, derived metrics that are most commonly used, and these 5 that you see on this particular slide: productivity, defect density, effort, schedule variation, cost of quality are one of them. Now, to understand derived metrics a little more, it will be appropriate to understand the categories of derived measures. In any scenario, I mean, you when you are dealing with n number of software metrics, when you put it into certain categories or you group it according to their categories, it's much more easier to understand them. So one of the most common ways of categorizing software metrics is using these 3 categories, time and tested categories, I should say: cost, quality, and time. I mean, just remember the magic triangle that comes to the mind immediately when we think of these 3 categories. So when you have a set of software metrics which you want to measure in a project, try to think about metrics in each of these 3 categories, and if you have 2 or 3 metrics in each of these 3 categories, you will be pretty much you can be pretty much sure that you have a good set of metrics that you want to track for a project. Another way to group the derived measures would be to group it based on process, product, or service. Slightly different from cost, quality, time, but here the concept is a process is more of an efficiency related metric, whereas a product is more of a effectiveness related metric. All right, I use the explanation that also process is something that is internal, and product is something that is visible or external, and services is more of SLAs for production support and infrastructure management kind of projects, which are more of a service in nature. So I hope by now that you would have got some sense of what is a base measure and what is a derived measure in a software project, and I hope that you would also have got a sense of what and how should we look at the health of a software project. We just need to look at the various groups of metrics like cost, quality, and time, and then try to ensure that a project is performing well in all these three categories. That would ensure that the project software health is good, and by doing that, we would also be able to make sure that if there is any change needed in the way a project is executed, or the way the process is executed, we would be able to take a decision regarding that. Any metric, unless it gives you some purpose of inferring something or being able to judge and compare with other projects, I mean, unless we are able to do that, there's real no purpose in tracking that particular metric. And by following this approach of understanding the derived metrics and being able to categorize them into proper groups helps us do that in a much better way. So thanks for listening, and looking forward to your comments. And please also ask your questions if you have any through this website, and we will be happy to respond to them. Thanks a lot.